Professor, you're mute.
Prof, you're mute. نقطة join.
Silvio, شوف المدير. Sorry. I was this was mute. Okay, now I can. What I was saying is that you can have a look from the textbook. It is on page 277. It's problem 8.4. Okay, so that's what we want to go over and try to solve based on your request that you have some difficulty in trying to find the eigenvalue. So this is the matrix B. It is 3 by 3. So let me ask you, Silvio, what would be the characteristic polynomial of this matrix? What order? What will be the order of the characteristic polynomial? Anyone wants to answer? You can raise your hand in the comment section. Denise? Denise, any comment here? So this is 3 by 3. So here we expect a matrix which is, we expect a characteristic polynomial which is in the third order of lambda, assuming that lambda is the root of this polynomial. And in this case, we'd expect immediately what we do is that we will try to identify or to find what is b minus lambda I. And b minus lambda I, it is 3 minus lambda minus 1, 2, 5, minus 3 minus lambda, 5, 1, minus 1, 2, minus lambda. Okay, so this is what we always do. So we just try to subtract the identity matrix multiplied by lambda, and this is what we obtain. And then and then immediately the determinant of this matrix, we set this one to 0. Okay, and when we set this to 0, we have to write down the determinant. And the determinant of this 3 by 3 matrix is going to be the following. Let's write this one step by step carefully. So here we have 3 minus lambda, 3 minus lambda times, we have to multiply with these two terms. Now these two terms, we can multiply this with minus, this with minus, and this can become as lambda plus 3 times lambda minus 2 plus 5. I believe you can see this. Okay, not perfect. I'm sorry. Okay. Give me just 1 second. We are good. Okay. So this is 3 minus lambda, lambda plus 3 times lambda minus 2 plus 5. Then we have here plus 1, because this is minus 1, it becomes plus 1. Then we have 5. This is 10 minus 5 lambda, 10 minus 5 lambda, and then minus 5, okay, plus 2 times minus 5 plus 3 plus lambda. I believe this is all. And then here, from here we get that, first of all, this is, wait a second, is this correct? Minus 5. We said plus 3, I wrote minus 3. And wait a second, this is good. So then we get, this is lambda minus 2. This whole term is equal to 5 times lambda minus, this is 5 minus 1 minus lambda. Okay, so let's expand all of these terms. Okay, so let's see what we get. And by the way, I just noticed that I could not hear you. A mund flisni pak sa të shoh, sa të konfirmoj pak që ju dëgjoj? Se kisha të fikur këtë.
Në dëgjon?
Now I do. Pra ishte besoj keni folur, po sikam dëgjuan, sinqerisht tani vura re. Atëherë, vazhdojmë me kujdes. Tu we get 3 minus lambda. And let's time ourselves. Let's see how fast we can do this one. So this is equal to lambda square plus lambda. You can hear also this one. And it's okay. So here 3 minus lambda times lambda square plus lambda minus 6 plus 5 plus this is 5 minus 5 lambda. And then we have minus 10 plus 6 plus 2 lambda. Let's continue again. Here we obtain, what we get is that we have, let's multiply the lambda terms first. This is minus lambda cubed. Then we have minus lambda squared. This is minus 6 plus 1. This becomes minus 1. So this is, what did I say? This was minus 1, right? So this was minus 6 plus 5. Yeah, that's correct. It's minus 1. But then here we get minus lambda cubed, minus lambda squared, plus lambda, plus 3 lambda squared, plus 3 lambda, minus 3. It's good if we put together some terms. So this minus 10 plus 6, this is equal to, so we write this one minus 4. Okay, so this is minus 4. This 5 minus 4, this is 1. Okay, so this becomes 1. We said here minus 3 plus 1. We're done with this one. Then we have minus 5 lambda plus 2 lambda. It's minus 3 lambda. Minus 3 lambda. Okay, we wrote all the terms. Now this can become a little simpler because here we have lambda square. Lambda cube, sorry, plus lambda square. What are the lambda square terms? Here we get minus 1 plus 3, and it looks like this is all, but you can correct me if I'm wrong. So we get here, this is a 2. Yes, and let's go after lambda. This is plus lambda multiplied by, this is 1 plus 3, 4. So it's just 1. So this is lambda. Okay. This is the lambda. We are left only with the constant numbers. The constant numbers, lambda, 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 this is minus 2. Minus 2, this is equal to 0. So it looks like we got here, and let's write this one plus 2 lambda squared. Okay. Plus 2 lambda squared. So we have a polynomial which is equal to, the first coefficient is 1. 2, 1, minus 2. So these are the coefficients of lambda cubed, lambda squared, lambda to the power 1, lambda to the power 0. Now we need to find the roots of this polynomial. This is a third order polynomial. And here, how can we find the root? Let's try to determine some roots. What we can do is we can try to find what are the multiples of this minus 2. The multiples, so this is the polynomial, okay? The multiples of minus 2, they are 1, minus 1, 2, minus 2. And let's see if any one of these are the roots of this third order polynomial. Let's see, this is 1, so let's try lambda equal to 1, okay? We don't know what is the root, so we do 1 plus 2, it is 3, plus 1, 4 minus 2 is equal to 2. So lambda 1 is not a root. because when unless we did a mistake during the past, but let's move ahead with this one. We can confirm this later. Let's try lambda equal to -1. Lambda equal to -1. And here we get -1 plus 2. This is 1. 1 minus 1. No, wait a second. -1 plus 2. It's 1. 1 minus 1. 0 minus 2. It looks like this is not a root also. Okay. Let's try lambda equal to 2. Lambda equal to 2. When lambda is equal to 2, we get here 8 plus 8. It is equal to 16 plus 2, 18, minus 2, 16. Again, this is not a root. And let's try -2. Let's try lambda equal to -2. -2 to the power 3, it's -8. Plus 8, it looks like we have no chance. I mean, this is -8 plus 8, 0. Then this is -2 is -4. So this is also, apparently, this looks like it's not a root. Let's check if we made some mistakes here. No, maybe we don't have a root. This is lambda square plus lambda -6 plus 5 is 1. 3 minus lambda plus 5 minus 5 lambda plus -2 minus 4, 2 lambda. Okay. Then lambda cube. Oh, okay. We have made a big mistake because we have a negative sign here. Yes. So you see here, we forgot this minus sign here, which we should have been a little more careful. So I'm talking about this one. And any other mistake we have here? So this is minus lambda cube. This is correct. It's minus lambda square. Okay. Now, you know what? Let's check again. If lambda 1, lambda -1, and 2 are roots, let's see. If when lambda is equal to 1, we get here -1 plus 2. This becomes, because this is going to be -1 to the power 3 plus 2 times -1 square plus 1. Wait a second, we're trying 1 actually. Let's try this one. -1 plus 2 plus 1 minus 2. Is this a root? What can you say about this one? Is 1 a root? -1. -1, this is 1 plus 1, 2. It apparently it's a root. So lambda 1 is a root. Can you confirm this? Because 1 cubed is 1. -1, this whole term is equal to -1. Plus 2, this is -1 plus 2, it's 1. Plus 1, 2. Okay, so we found one root. Lambda 1 is a root. Good for us. Because now this is, so we say yes. If this is a yes, then we say that lambda -1 is a factor of the polynomial in third order in lambda. Okay, so that's what we obtain. That what we need to do, we can divide this whole polynomial by lambda -1. If we divide it, we get the following expression. So we have here, let's multiply everything by -1. We get lambda cubed minus 2 lambda square minus lambda plus 2 divided by lambda -1. Okay. Then here we get lambda square. So this is lambda cubed minus lambda square. And then, yeah, that is correct. We change the sign. This is minus. We make this plus. These are cancelled out. We get minus lambda square plus lambda. This is minus lambda square minus lambda. And then here, this is minus lambda. This becomes here minus lambda square plus lambda. Then we have to change the sign because we have to subtract. This becomes plus minus. So they cancel out. We get here minus 2 lambda plus 2. And this is minus 2 lambda. So this is minus 2 lambda plus 2. Then this becomes plus, this becomes minus. This looks like this is equal to 0. So it looks like we found one root, we divided the polynomial, we got this, and finally we get this term. Now this term, this can be multiplied as lambda minus 2 times lambda plus 1. So it looks like the whole polynomial in order 3 in lambda, it can be written as lambda minus 1 times lambda plus 1 times lambda minus 2. So we found the 3 eigenvalues, okay? That's good for us. And the moment we find eigenvalues, the next step is to try to determine the eigenvectors. To find the eigenvectors, can you follow? Can somebody confirm this? Are we good? Yes, okay, thanks, Alisa. So we found the, then we have the, so wait a second, so we thought this would be the roots, okay? Then it looks like we have lambda 1 is equal to 1, lambda 2 is equal to minus 1, and lambda 3 is equal to 2. Now, I can ask you one question. What is the determinant of matrix B? Any idea? What is the determinant of matrix B? The determinant of matrix B is equal to lambda 1 times lambda 2 times lambda 3. So this is a property of the eigenvalues of a matrix. So this means that 1 times minus 1, it's equal to minus 1 times 2 is equal to minus 2. So determinant is minus 2. What about the trace? What is the trace of B? Trace of B is the sum of these terms, of the diagonal terms, okay? So trace is equal to 3 minus 3 is 0 plus 2, we get 2. Now, if we add up the eigenvalues, 1 minus 1, 0 plus 2 is also equal to 2. So the trace is also equal, so trace, or you can write this on TR of B, is equal lambda 1 plus lambda 2 plus lambda 3. Okay, so we have also these interesting relationships. But now the question is, let's try to identify what are the eigenvectors. Now, to find the eigenvectors, what we need to do is that we have to start for lambda 1 equal to 1. If we assume that lambda 1 is equal to 1, we need to substitute in here and see what is this matrix. Here we have 3 minus 1, this is 2, minus 1, 2 again, 5, minus 3, minus 1, this is minus 4, and then we get a 5. So here we have two relationships. And now a valid question that we can ask here is the following. What is the rank of B minus lambda I? Okay, this is a valid question. And for sure, the rank of this matrix, it should not be equal to 3. Okay, the rank should be at least 1 lower, because we know that the determinant of this matrix is equal to 0 for lambda 1 equal to 1. And we can check whether this is true. So we have here 1, minus 1, 2 minus 1, it is 1. Now, let's try to see if we can easily, wait a second. So what we can do here, can somebody see that the rows here are linearly dependent? I cannot see it right away, but this could be minus 2 times minus this, minus 2, minus 4. So we have here 2 minus 2. I cannot immediately see this, but probably we can see it when we try to obtain the eigenvector, which is ABC. This should be equal to 0, 0, 0. And by the way, now just to have a short confirmation of what we found here, is that we can have a look. Let's try to share here the entire screen. And this is just a small confirmation of what we have. I might have here MATLAB. Can you see my screen? Can you see my screen?
Yes.
Yes, okay, thanks for confirming. So let's write for a moment. This matrix B is equal to 3 minus 1, 2, 3 minus 1, 2. Then we have 5 minus 3, 5, 5 minus 3, 5. And we have 1 minus 1, 2. 1 minus 1, 2. So we can write this one here, or we can copy. So matrix B is this. So this is the matrix B, and we can say P is equal to polynomial of B. P is equal to poly of B. And these are the coefficients of the polynomial that we found also in here. So the coefficients are 1, minus 2, minus 1, and 2. So it looks like we have made a mistake then. 3 minus 1, 2, 5 minus 3, 5, 1 minus 1, 2, 1 minus 1, 2. So this is 1 minus 2. No, this is correct because, okay, this is minus 1. Change over there. This is minus 2. Okay, this is good because then don't look at this one, but look at this one, the final version. Okay, so it looks like the polynomial is okay. This is the characteristic polynomial, and then we can say the eigenvalues would be the roots of this polynomial P. The roots are minus 1, 2, and 1. That is correct. So these are the eigenvalues that we also found, okay? The first eigenvalue, we found it by substituting 1 in this polynomial. The polynomial was satisfied, which meant that lambda is equal to minus 1. Sorry, lambda minus 1 is a factor of this. We divided, everything looks good. And now, what we can try here, we can prove this one numerically, but we can have a short look in here. So we can define a new matrix, which is A equal to 2 minus 1, 2. I'm reading the matrix on the board, which is B minus lambda I. 5 minus 4, 5. 5 minus 4, 5. And we have 1 minus 1, 1. 1 minus 1, 1. Let's see what is the rank of the little matrix A. It looks like the rank is equal to 2. And as we said, it cannot be 3 because otherwise the rank would be 3, and then the determinant would be different from 0. Okay, so now let's switch back here. You're presenting. Stop presenting. So let's see what is the first equation we obtain. We get here 2a minus b plus 2c. This is equal to 0. And then the second equation, actually, the second equation, we can pick up also the third one, which is going to be a minus b plus c. This is equal to 0. Present now. Okay, so then we have to find A, B, C, which satisfy this this condition, and so let's say here A, B, and C, and in this case we can set one of the variables as a free one. So we can set, for example, C equal to 1. If we set C equal to 1, we get the following: we get A. Or we can do it like this. So from these two equations, we can subtract the second from the first one. So we can do the first one minus the second. We get A plus C. This is equal to 0. Okay, is this correct? Can you check this? So 2A minus A, it's A. B plus B is 0. 2C minus C, this is C. So then we get A is equal to minus C. So this is, since one of these variables is going to be free, this is what we get. The other relationship that we can construct is that we can get the first one minus 2 times the second one. Okay, we get 2A minus 2A is 0, minus B plus 2B. This is going to be B, and this is going to be 2C. It looks like B is going to be 0, right? I might get confused here. So let's multiply the second
One.
equation. This is minus 2a. No, okay, plus 2b minus 2c is equal to 0. This is easier. So let's say this equation and this equation, the two a's cancel out each other. So two a's cancel out each other. Then here we get b. Okay, so then b is equal to 0. Am I correct?
Yes.
Okay, so we found the first eigenvector. Now, let's take this away for a moment because this was clear to us. And then it looks like this is the first eigenvector, but this is equivalent to this 1 over the square root of 2 multiplied minus 1, 0, 1. So it is good to have the normalized to scale 1. This is the first eigenvector. The other eigenvector, we try for lambda equal to minus 1. If we substitute here lambda equal to minus 1, let's try to find, let's substitute it right here. So 2, we get it from here. 3 minus minus 1, this is 4. This is minus 1, 2. Then we have 5 minus 3 minus 1. This is minus 4. This is 5. It doesn't change. 1 minus 1. 2 minus minus 1. This becomes 3. So this is 3. We multiply this with ABC. And this should also be equal to 0, 0, 0. Then let's see what are the equations we can obtain. So this was the first eigenvector. And from this expression, we get the full, So let's use the first equation and the third. The first equation, it is...
Prof, shouldn't the minus 4 be minus 2 in the matrix?
Let's see. I think you are right, because this is minus 3, minus minus 1, that is minus 2. That's true. That is minus 2, yes. And then it looks like it is very obvious that the second row is equal to the first row plus the third, right? Would you agree on this one? Because 4 plus 1, 5, minus 1, minus 1, minus 2, 2 plus 3, 5. Thanks for correcting me this. So let's use the first and the third equation. We get 4a minus b plus 2c, this is equal to 0. Then we have a minus b plus 3c, this is equal to 0. Let's set c equal to 3 as a free variable. So, which means that in this case, what do? We just say that, let's take away this equation, and we can say that ABC, this is equal to, let's see what is a good choice for C. So the first thing that we can do, we can subtract from the, no, I still made a mistake, right? No, it's not, no, we're good. So here we have 4a minus a. By subtracting, we get 3a, b plus b, it is gone. 2c minus 3c is equal to minus c is equal to 0. Okay, so it is reasonable to use c as a free variable. Then, can you give me a pair of a and c which satisfy this condition? We can set a1, c equal to 3, right? Because 3a is equal to c. This is a pair of numbers which is good. The other equation that we can obtain to find the value of b is the following. Let's multiply the second one by minus 4. The second equation, it becomes minus 4a plus 4b minus 12c. This is equal to 0, okay? So I just multiplied the second one by minus 4, and let's have a look at these two equations. Let's add these two together. 4a minus 4a is 0. 4b minus b, this is 3b. And here we have minus 10c. This is equal to 0. In this case, assuming that c is equal to 3, we have here 3b is equal to, wait a second, 3b is equal to 10c. So if c is equal to 3, we get 30. This is 10. Okay, so this is the second eigenvector. If we want to normalize this eigenvector to 1, what should we divide with? What is the magnitude of this vector? 1, 10, 3. Any idea? The magnitude of this vector is going to be the 1 square plus 10 square plus 3 square all square root. So this is 109, 110. So this is divided by the square root of 110 multiplied by 1, 10, and 3. This is the second eigenvector. The third eigenvector, we have to search for it, assuming that lambda 3 is equal to 2. And then if it is equal to 2, we have 3 minus 2. This is 1. Minus 1, 2. Then we have 5. Minus 3, minus 2, it is minus 5. And we have 5. It does not change at all. 1 minus 1. And 2 minus 2 is equal to 0. Okay, so this is the third expression. Times ABC. This should be equal to 0, 0, 0. Then let's pick up the first equation and the third. This is A minus B plus 2C. This is 0. The third one, it is A minus B. This is equal to 0. Okay, or we can also we can also pick up the second one. If we pick up the second equation, we can divide all by 5. This is A minus B plus C. This is 0. Then the first manipulation we can do is that we can subtract from the first one, we subtract the second. So we get A minus A 0. A minus A 0. But then this is the same. So what do we obtain then? A minus A 0, 0. This we get C is equal to 0. Okay. So when you have this A, B, C, we immediately get a fixed value for C, which is 0. And then the other trick that we can do is that if C is equal to 0, what do we get? 1, 1. Okay. This is 1, 1 because we have 1 minus 1. This will be equal to 0. Okay. So this will be the third eigenvector. So we get here 1 divided by the square root of 2, 1, 1, 0. Okay. So we have this matrix. We found the eigenvalues and the respective eigenvectors. Any question for what we did here? If not, we can have a short break here.